No, let's just
Proceed.
proceed, and then we'll get to the actual session.
All right. Yeah.
I talked about AB. Ne?
Yeah. Yes.
You have 40, and then BC it's 30, and
Okay.
then AC will be maybe, let's say, 25.
Yeah.
Now you have to construct a triangle using these lengths.
Yeah.
Do you know how to do that?
Yes.
Yeah, so that's your true length. That's your true shape.
Huh? Wait.
Using these length, I'm a length now. Using these numbers or
Wait.
measurements, you will have to construct a triangle. Triangle has three sides, and then
Yes.
the
Triangle
side,
has three sides, but I'll use the true lengths, right?
yeah,
Oh, I'll take the true lengths and then construct a triangle.
yes,
Okay, and then that's the true shape.
that's the true shape. That's where you have to scribe a circle, either circumscribed or inscribed.
Mm,
Yeah.
okay. Okay. And I think I understand. I think I get it. On which view? Okay, yeah. Where must I draw the true shape?
The true shape you'll draw it separate
Oh,
on its own.
separately.
Yeah.
Okay.
Yes.
Okay, thank you. But how must I know that? How must I position it? Because I'll have the measurement. I'll know A is maybe 40 millimeters, B is 30, and C is, I don't know.
Anyhow,
Anyhow, okay.
anyhow.
Yeah, okay. Yeah, I think I get it now.
Yeah.
Okay, thank you.
Sure. Any questions, guys, with regards to the descriptive geometry before we start with the solid? Any questions with the angle, true inclinations to the VP or to the HP, or the true length, or the line that is parallel to the XY from the top view, or the perpendicular lines? Any questions? Okay, I think we should start with the session for the solid geometry. I'll just present a window now. Okay, so with regards to solid geometry, we moved from projecting regular polygons to determining the true shapes of the cut surface, and then we'll also go to the cylindrical conic sections. Last year, we did solid geometry, but we didn't do, I'm not sure if we did, no, we didn't. We didn't get into the cylindrical and conic sections, so we didn't do cylinders and cones. Am I right, guys? So in this session, I want us to focus specifically on cylinders and cones. Cylinders and cones. So cylinders are not polygons or the regular geometrical shapes. So dealing with cylinders, you know that the first thing that you need to do when you come across a circle or a cylinder, it's one of those that where you have to divide the circle, the circumference of the circle into 12 equal segments. So in solid geometry, dealing with cylinders, you will deal with the diameter of the cylinder. Maybe let's say they gave you the diameter and they say the diameter of the cylinder is 30. Now you have the diameter, and then you also have the length or the height of the cylinder. looking at the orthographic here under the word projecting circles. The orthography there, you can see you have a circle in the top view, which is the top view of a cylinder, and then you have a front view. So it means you will need a diameter of the circle and the length or the height of the circle in order to construct a circle. And then sometimes you will have a problem that says that has a tilted cylinder at an angle, say 45 degrees. Then you have to use the other methods of constructing that cylinder. So looking at this orthographic projection on your left, you have a circle in the top view, which is the top view of the cylinder. So from a question, you won't be having those line segments there. You'll only be having, maybe sometimes they'll just give you a paragraph, and they say draw the top view and front view of a cylinder that has a diameter of 30. Then you'll start by scribing or drawing the circle. So you have 15 radius, and then you scribe a circle using your compass. Then you have a circle of diameter 30. And then the second thing is you'll have to divide the circumference of the circle into 12 equal segments. After dividing, you have to number those segments. It doesn't matter where you start. Doesn't matter where your 1 is. Anywhere. So you number 1, 2, 3 up until 12. And then you have to project those segments up to the front view to determine the front view of your cylinder. Now in the front view, you will need the height of the cylinder, which will be given in the question. And then you measure, maybe let's say it's 70 millimeters there. You measure 70, and then you scribe your cylinder. Now, your cylinder in the orthographic projection is presented by certain lines. So you have the outer line from 3, which is that outer line there, outer line side. From 3.3, there represents the outer line on your side. And 9 on this side represents the outer line on the side. That's where you'll measure the height of the cylinder. And obviously you'll have the top there and the bottom there. Moving to the tilted cylinder on your right. Now, this is where you realize that a cylinder has 2 parts. So you have a top part and the bottom part. You know that if it's a cylinder, looking at this front view, you can't see what's happening on the top side there, on the top part. But you know that if they mention that this is a cylinder, then it means the top part is a circle and this bottom part is also a circle. So just be aware that you have or you are dealing with 2 circles when you're dealing with a cylinder. Now, looking at this drawing, the orthographic drawing, let's say you have a paragraph saying draw a cylinder tilted at 45 degrees. Draw a top and front view of a cylinder tilted at 45 degrees with a diameter 30 and the length of 70. So now the first thing you're going to do is you're going to draw a circle. Or maybe we have a blank page and a paragraph. That is a question. So first thing you're going to do is draw a circle with a diameter 30, as mentioned in the question. So you have a circle at diameter 30, which is this one, and then you will divide the circumference of that circle into 12 equal segments. But you need to take this into account. If they set a tilted cylinder, it means the circle that you are drawing there, it's not the actual top view. It's called a help view. So it's not the actual top view. It's just going to help you to assist or guide you in scribing or projecting the front view. So now after dividing the circumference of the circle into 12 equal segments, you will project, as I told you, that you need the outer lines or the outer segments. In this case, it's 9 and 3 on the side. So it's 9 and 3 there. That's point 3. And then you project point 3 there where it meets with the XY. That is where the angle of the tilted cylinder comes into mind. So you'll go back to the question and check the angle. They'll say 45 degrees. So it means where the line segment from 3, the construction line from point 3 there, where it meets with the XY, that's where you'll put your 45 degrees set square and scribe a construction line across in 45 degrees there. You'll have a line. And then from there, you also project all those segments from 1 to 12. All those segments where they meet with the XY, where they meet with the XY axis there, you have to use your compass and use the swing method. Say for 9. So you'll place your compass at 3, where the 45 degrees line starts. You'll place your compass there, and then also at 9 there, and inscribe a construction swing line where it meets with the 45 degrees line. That's where your cylinder starts. That is where your cylinder, and you will repeat the same thing with all the segments. But you also know that those segments, because this is a cylinder or it's a circle, 10 lies on the same line with 8, 11 lies on the same line with 7, 12 with 6. So another thing is, after scribing or projecting those lines to project a cylinder, you'll also have to use their length or the height that they gave you. Say it's 70, then you'll measure 70 there. And then also you'll have to use your 45 set square to scribe the top part of the cylinder. After scribing that part and this part, now you have a cylinder. Now you need to number this top part according to the numbers that you have here. According to the numbering that you have here, this numbering must correspond with this one. So if it's 9 here on your left, here in this view, in the helping view, you'll have to go through up to there, and then you number 9. Also with 10 and 8, from this help view up to the cylinder, to the top part, you'll number 8 and 10 there. This will help you to scribe the top view and the other views if required, the left and the right. So now, after
So,
numbering, sorry.
don't you perhaps like have a drawing that you can do like step for step with us to help us understand it better? Like doing a drawing with us, showing like how you move your how to number it 1, 2, 3, 4, 5, 6, 7, 8, 9, for example.
Yes, I have a video that I'll put on a group
Okay, thank
after
you.
that. Because now I don't have a camera that, like, where I can show you the actual part. Or you want me, how will we do it? Can we do it with like actual, should I draw like right now? Do you want to see what I'm explaining?
Yes, yes, please. Because right now we're looking at like a drawing that's already been done. So we're not sure whether we're looking at the same things that you want us to be looking at, because we just see lines there and you're just pointing at them and it doesn't make sense. So if you just draw it and then as you move along, we can see what line you're making. That would make things way better.
Okay, please give me a second to just set up. Okay, so at the moment, please write the following. Say we have a cylinder with a diameter 30. A cylinder with a diameter 30 and tilted at an angle 45 degrees, and the length of the cylinder is 70.
Tulani,
Yes.
can I please ask, how will you know that you must tilt it to the left or to the right?
Oh, that's also going, it must be mentioned in the instructions.
Okay.
Yeah. Okay, so now it means I should stop sharing the window, right? To enable the camera so that we can see. Okay. Uh, can you see me, guys? Can you guys see me? Oh, okay. So you had a question that says a cylinder tilted at 45 degrees. So let's say I have a line. So first thing you need to know is you have the diameter 30, which the radius will be 15. Then I'll scribe a half view of 30 diameter 30. Scribe a half view with diameter 30. I'll show you just now what I just did. So, okay, so since, let's see if you can see. Oh, yeah. It shows, but not clear. It's not clear.
Can you please maybe use an ink pen and not a pencil so that it's going to be visible?
Yeah. Right. So it means it will be a bit messy. Just to demonstrate. So when they say you have a circle with diameter 30, first thing you draw the circle. Then the second thing is to divide the circumference of the circle into 12 equal parts. So I'll just do that and I'll show you. and then you number those parts: 1, 2, 3, 9, 10, 11, 12. Okay, so is it upside down? Can you guys see?
No, it's fine. We can see, but we can't see the numbers properly.
Oh, okay,
Yeah.
okay, so after numbering the circle into 12 equal segments, now you project those segments to the XY. So you project the segments to the XY. So you have XY there. You project the segments to the XY from 1, 2, 3 up until 12. So you'll project those lines to the XY. To the XY axis there. And then from there, now this is where you have to check whether your angle is tilted at, not your angle, your cylinder is tilted at which angle. And then from left to right, from left or from your right. So in this case, from the left. So it means from 3. So it means from here, which is 3 there. That point is 3. I'll put my 45 degrees set square and inscribe a line at an angle 45 degrees. So you will be having something like this. So you'll be having a line at an angle 45 degrees. Then from there, you're going to use a compass. Place your compass at point 3 there. And also maybe in 9 there. You'll scribe an arc where it meets with the 45 degrees line. That's where your cylinder starts. You'll scribe all those line segments to the 45-degree line, like that, using your compass. So from here, you now know, okay, my cylinder starts here and there. Now you'll use your 45-degree set square again. From that point there, from this point, all these points, you'll scribe construction lines in 45 degrees. In 45-degree line there. So you'll have lines going in that direction. We have lines going in that direction. Hope you can see. And then from this point, that's where you will look at your length, the length of the cylinder. So let's say it's 70. Then you measure 70 from there. You'll say, okay, that's my 70 right there. That's my 70 right there. And then you will scribe using your 45 degrees line. You'll put it there, and then you have a line at an angle. Like that. Now you have your cylinder. Now you have your cylinder. You are left with numbering the cylinder in the front view. You have your front view cylinder. You just left with numbering. So how do you number the cylinder? Using the numbering here, okay, that you can see, but it's 9 there. That's 9. This is 9. You will follow 9 through up until to the top part of the cylinder. This is the top part of the cylinder. And then this is the bottom part. You know that in this top part, there is a circle. And also in this top part, there is a circle. So now you'll follow this 9 up to there. you know, okay, that's 9, that's point 9, that's 9 at the top. And then you will also follow through from the second point from 9, which is 10. Then you follow through, you number 10 there. 11, all those points, you number them in the top part of the cylinder. 11, 12. So other points align with the others. So for example, 11 at the top there aligns straight with 7 at the bottom of the cylinder. So the top goes with the 7, the 12 with 6, 1 with 5, 2 and 4. So you, and in the numbering you'll have, say, maybe 11/7, 12/6, 1/5, and 2/4, and then 3. 3 and 9 are going to be alone, are going to go alone. There won't be a slash because 9 has its own point. It doesn't align with anything, and also 3 doesn't align with anything. So 9 and 3 will be on their points. They won't have other numbers on their side. So from this part now because you have your cylinder in the front view, you have to scribe the top view. Remember, this is not your top view. This is not the actual top view. This is the help view or the help drawing. This is not your top view. Now you have to scribe your top view. So how do you do that? From the bottom part of the cylinder, this part, from this part of the cylinder, you'll have to project lines perpendicular to the XY. Lines that go perpendicular to the XY to the top view. So you'll have a bit of messy lines here. Again, you'll have to construct lines from this help view parallel to the origin. So from this help view to your right, you'll have lines like going like that. So these lines will have to meet with these ones from the top, from the front view, in order to create the top view. So I'll start by constructing these lines from this view or this help drawing to your right. So you'll scribe all from 1 to 12, all those points. 3, 2, 1. In construction lines, you'll have lines like that. You scribe lines like this. So now this is where the numbering gets important. You have to be careful with your numbering. If you're still not familiar with numbering, you can still number the bottom part. You can still number the bottom part. So if it's 9 in the first point there, it means it will be 9 also there. So you can number the bottom part also the same way you numbered the top part. So from here, you'll have to scribe or construct or project all those points in the bottom part to the top view. So you scribe all those points down to project your top view. So you'll have lines perpendicular to the XY going to the top view. This is your top view. But remember that this actual circle is not your top view. Is not your top view. So where these points or these lines meet with those lines that you scribed to your left all those lines that you scribed to your, not to your left, to your right, there. These lines are going to create the top view, the bottom part of the top view. So because this is the bottom part of the cylinder, so here will be the top view, the bottom part of the top view of the cylinder here, because these lines, these perpendicular lines are from the bottom part of the cylinder. Then after getting this, because if you have 9 there, where this 9.9 meets with the 9 from this side, there will be a point there. So where the 9 meets with this 9 from this side, there will be a point there. Where the lines intersect, you will have a point which will number it 9. And then you will repeat the same thing with the other segments or the other points. Where point 11 line meets with 11 from the front view, that will be your point of the front of the top view, but the bottom part of the cylinder, the bottom part of the cylinder. So from there, you're going to move to the top part of the cylinder. That's why you'll also have to project the lines perpendicular to the XY to the top view there. You also have to project lines down perpendicular to the XY into the top view. Do you guys follow? Maybe I should pause for a second to take questions. Any questions, guys? Questions, guys? Can't see a thing. Any questions, guys, before we continue? Okay. Okay, so I said you should have lines perpendicular to the XY down to the top view. So this is how you have your lines. So you have to project lines from the top view, the top part of a cylinder. This is the top part. You project lines down to the top view, perpendicular to the XY. Okay, lines. So you need to understand that all these lines have numbers. All these lines have numbers. So if 9, as I've explained in the bottom part, so if 9 intersects, if this 9 where it intersects with the 9 coming from the help view, from this view, where the 9 on the upper part of the cylinder, where this 9 intersects with this 9, you have a point, which is your new 9. You write 9 on that point. Where 7, where it's 7 and 10, where that point intersects with 7 on this side. Let's say you have 10/7. You will start with 7. So where this line coming from the front view down to the top view, where it intersects with the 7 from this side, this will be your 7 here. Where I'm pointing is your 7. Where this line goes across there, where it meets with 7, it will be your point. You move to 6, maybe 6 is right there. Then where's 6 on the front view? 6 will be from there. So you check that line from that point, perpendicular to the xy. So you follow that line. So where it meets with 6 from this help view, that's your point, which will number 6. Again, from maybe let's say now to 5, where this 5 from that line or from that point intersect with the 5 from this help view, that will also be your point. That will also be your point. So you repeat the same thing up until you have maybe something like this. The points must follow up to when you have like something, the dots like this. So these points are your top view. The top the top part of the cylinder in the top view are represented by those points or those dots. And then now from here you'll have to go back and refer to which line will be visible from the top view. So looking at the drawing from the top, you'll have to know which line is visible, which lines are visible from the top view. Any questions, guys? Any questions, guys? Or should I go back to the presentation? Before going back to the presentation, guys, any questions? Okay, no question. None. Okay. So I'll just show you what I was explaining in the I'll just show you what I was presenting now in the drawing board. So tilted cylinder. This is what I was explaining, but this one is tilted from the other angle. So let's say this line is at an angle of 45 degrees. So this is what I meant when I said this one is the bottom part of the cylinder. This is the bottom part of the cylinder. This is the top part of the cylinder. So you have two circles here. It's just on the specific drawing. There is no help view here. So you'll be having maybe a help view somewhere there. Like in the previous, in this one. You see here, there is a help view that is numbered. So this when they say you have a cylinder at a diameter of 30 millimeter, diameter of 30. So you have that circle there, which is your help specific drawing. So you need to know which part will be visible or which lines will be visible viewing this drawing from the top. So that is the method that you learned from the other drawings, from isometric, from perspective, you know, when you're looking at something from the top view, you must know which lines are going to be visible from the top. You must know. So moving from the cylinders to the cut cylinders, cut cylindrical sections. So this is where things get confusing, because now a cylinder doesn't have corners, but when there is a cutting plane, you need to be careful about the cutting plane, because if you have the top view like on this one, I wish I can also explain this one while I'm drawing, but guys, having a top view and a front view with a cutting plane. So the cutting plane, you must know that a cutting plane will always be in the front view. So having the cutting plane there, to know where exactly the cutting plane cuts the cylinder, you must have the side view. You must be able to view the drawing from a side, because if it's 11 there, and then the draw the line or the cutting plane, you see that it cuts on the line, the 11 and 7 line, because it's 11 there and then it's 7 at the bottom. So this line represents 11 and 7. So the cutting plane cuts right there, but you can't see where it cuts in the drawing here. So to see, you have to have the right view on this side. So this is the right view. So you are standing here on this side, looking directly to that cutting plane. From this side, looking directly to that cutting plane. So the looking at this line specifically for 11 and 7, the cutting plane cuts right there. So projecting that point across where it meets with 11, the point 11 there, from the top view, this will be your point there. This is where the cutting plane cuts the cylinder, right there. So to specifically know where the cylinder is cut, we have to have a side view. But also in the top view, it's just in the top view, because you'll be viewing from the top, you will see that the drawing, the cutting plane cuts the cylinder. You will think that it cuts the cylinder and all those parts, because as you can see, the sectioning there, it's all over that top view, except that part, because it cuts it there in the bottom there. But if it cuts, it has to cut there in the corner, then you'll have a full circle that is sectioned, because looking from this from the top view, and then having the cutting plane from that corner going straight to this corner, then it means you'll have a full circle with the sectioning or the hatching lines. You have a full circle with hatching lines, and then they'll say also find or draw the right view. And then in the right view, you have to use the same method that you used when finding the top view, where that line 1 intersect with where the cutting plane cuts line 1. If line 1 is this line represents 1 and 5. So it's 1 and 5. Where the cutting plane cuts 1 and 5 there. So this is 1, you project it to your left and then up. This is the 45 degrees line from the top view to the left up, where it meets with the point where it cuts, the cutting plane cuts line 1 and 5. That will be your point there, which is for 1. Obviously for 5 you have to go down and also project to your left. The very same line that is aligned at 1 and 5. You will have your points there, which is the same place where the cutting plane cuts the cylinder in line 1. So you'll just have different line segments. Remember, you divide the circumference of the circle into 12 equal parts so that you will have the line segments, which will guide you when you have a cutting plane. I will post the videos that I recommend that shows you exactly how to do everything, like taking you through the drawing process from a blank page to solving the cylinder problem or the cone. So conic sections or cones are a bit easier than the cylinder because we're dealing with only one circle at the bottom, and then we just have a tip there at the top, so we don't have two circles. In cone we have only one, so but it's similar to the cylinder. It's just with the cone projecting from this help view. When you reach the angle of the cone there, maybe let's say it's 30, this is where all the line segments from this view they'll have to go to the tip there, to the T, the point labeled T there. All these lines from when they intersect with the line at an angle there. So if it's 4, obviously 4 will go there. And then if it's 3 will also go to T. All those points will move directly to T. But I'll post a link with a video that shows exactly how you will have to project those lines or those views. And obviously these are the assessments. Any questions, guys? I can't see the questions. None. Okay. Any questions, guys, with regards to cylinders and cones and the conic sections or the cylindrical sections? Questions?
I have a question.
Yes.
Yeah, can you please move up to slide 3, I think? No, slide 2.
Here.
No, slide 2. Yeah,
This one.
yeah. I did not
Okay.
understand. You see the bottom part of the cylinder
Here.
in the yes, there.
Okay. Yes.
I don't understand how I'll plot. Okay, I understand that how I must plot the points, but I just don't know what will I see and what will I not see. You see, when I have to outline my drawing.
Oh yeah.
Yeah,
I understand.
yeah.
I
Okay.
understand. So first thing is looking at the front view. Ne? Looking at the front view there, you have to know like numbering. The numbering of the drawing works on this one. Okay, let me start by explaining this bottom part. Looking from this front view from the top, looking from this drawing from the top, you will see from that line there, on the side we are at, So from this line, which will be 8, as you can see, the numbering there says 8 and 12. So you will see from there, from that point down to the top view. So you'll see from that line, from that point to 7, which will be 7 and 11 there, and then to 8 and 10, and then 9. It means all that part, and on the other side, because a cylinder is obviously, if it's 8 on the side, it means on the other side will be 12. Like here, it's 12 and then it's 8 there. So it means you will see from 12 to 8. This line from 12 to 8 is the line that you are going to see. From 12 to 8. From 12 here to the bottom, that line will not be visible. As you can see from 12, not from 12, from 8. That's 8 there. That's 12 and 8. So from this point into the drawing, that will not be visible. So that half circle won't be visible. Only this one on the outer side will be visible. And then moving to the top part, also from 8. Okay, in the top part, obviously, you will see the whole circle because you can see that it's open here. So if it's a pictorial view, you can visualize it. You have to visualize it that from when you're viewing from the top, you will see a cylindrical circle there. It means all those points will be visible there. You have a circle there. You have a complete circle because you're viewing from the top. You'll see everything there. And obviously, you know that from this point, which is 12 and 8, these are the outer points when you're looking from the front, from the top view. 12 is at the top and 8 is at the bottom. Those are the lines. 8 and 8 are the lines that are going to be visible because those are the outer lines. From 12, which it will be 12 there because it's 12 and 8. So the top part will be 12 because it's 12 on the hub view. So this will be 12. This will be 8 because it's 8 on the hub view. And then those lines 8 and 8 will be visible, and then 12 and 12 will be visible. Questions? Did you understand, Nonvi?
Yes, thank you.
Any other questions, guys? Or if you have, maybe you understand and you wish to also help someone understand, you can also comment, and I can go back, I can go where you want me to go with the presentation, and then you can explain that part if you want. Any comments or questions, guys? If there are no questions, then I think the session ends here. Or if you have questions about descriptive geometry, you can go back to descriptive geometry if you have any questions that you would like clarity before you submit. If there are any questions, guys, then I think we should end the meeting. Thank you for attending, guys. It really means a lot. Thank you for attending, guys. So we'll just end the session. Okay, guys, cheers.